All right, welcome back. So in this next step, I'd like to maybe add a couple more filters, something that'll make a substantial change, maybe something a little fun, a little weird. Let's start by, how about we'll create a filter that will limit each pixel to one of 8 colors. Give it a very retro look. So I'll say class, what are we going to call this? Colors uh, limited 8 filter. And let's just grab one of these other filters and start changing stuff. Grab this guy. Actually, not going to need the scale. And here, what does the user want to see? He wants to see 8 colors only. P for pixel. And we'll fill in the body just a moment. Let's see, this thing is going to need a palette of 8 colors. So let's put that in next. Let palette equals, okay, so this palette's going to be an array of RGBA pixels, right? And what colors do we want in our palette? Well, there's an obvious set of kind of mins and maxes. So let's start off with RGB. This will take just a moment. A pixel. So we'll do red is 0, blue is 0, green, RGB. So we do a 0, 0, 0. That should be black. Then of course we want a max intensity one. That would be XFF, XFF, XFF. And let's duplicate that. So we have a total of 8. That looks like 8. Yep. So what do we want? We want a pure red pixel. So that would be full intensity red. We want a pure green pixel for sure. So that would be this guy. And maybe later I'll have some nice names so we don't have to do these. But for the moment, I'll start with this. Okay, so we have pure red, pure green, pure blue. Now let's do the pure combinations. A red and green only. There we go. And a red and blue. And then finally, green and blue. There we go. So that was pretty obvious. What we did was each channel is either totally on or totally off, and when you do that, you get 8 colors. So there's a nice little palette for us to use. Let's call it palette. Actually, that's good, palette, because it's part of this limit 8 filters class. Okay, now we need some way to look at a pixel and find the closest thing in the palette. So let's go to our RGBA pixel class and let's add a method for doing that. So let's call this public var find closest pixel, find closest match. That sounds good. What's it going to take for an argument? Well, it's going to take one of these palettes. So we're going to say palette is an array of RGBA pixels. Now, oh, and of course it's going to return one of those RGBA pixels, whatever one's closest. So, what do we want for logic? How about we'll start with the, oh, this is going to have to be a variable. We're going to start with the, we're going to say closest match is equal to the first pixel. We're going to make an assumption that this array's got at least one element in it. In this case, that's a pretty darn safe assumption. That's all under our control. Okay. Next, we want to loop through and find out what's actually the... Oh, I guess the other... We need some way of comparing pixels. So let's... where would we put that? I think the RGBA pixel class would probably be a good place for that. Okay, so we need a method that'll tell us how close we are. So that'll be something along the lines of var closeness equals well, let's see. Closeness equals something. We'll have to write that up right now. So let's start writing that method. Public var. Actually, this will be a... Oh, that's not a var. That's a func. Thank you. And this one's also going to be a func. And let's see, we want to do a diff operation. Basically, I'm going to say pixel delta. That's a good term. What's the difference between this pixel and another pixel? So we're going to take in the other pixel. That's an RGBA pixel. And it's not your imagination that I haven't finished this last method. I thought we'd flush out this one and then use it. So what do we want to return? Let's see. I'm going to return an integer, and there's a reason for that. I could return a float. I could return a uint. But because of what we want to do, the simplest measure is just an int. So that's what we're going to do. Hey, before I forget, I'm just going to do this. I'm going to say the closeness is the pixel delta against and we can pass in self. Or we could do the other way around. Doesn't really matter. Actually, I think it reads better if I do it the other way around. I'm going to say self.pixel delta against that palette member. Hopefully that makes sense. And that's an int. And that's an RGBA pixel. Right. And it's complaining because we're not using them yet. Okay, let's continue on. What the heck are we doing? Well, we want to see how close two pixels are to each other, and that's a pretty easy operation to do, I think. To do that, we need to compare the R, the G, the B channels. So let's go return. Do we want to return? Yeah, we can do this all in one operation. Return. We're going to take the red channel and convert it to an integer. So we go self dot red, and I'm going to cast that to an int. And there's a reason why I'm casting it to an int. I'm going to subtract int other pixel dot red. Okay, and then take the absolute value of that. And that's the reason why. By casting it to an int, I'm making it larger than 8 bits. And I'm also making it signed. Because it's int, we can subtract these two and we may get negative or positive, and then we just take the absolute value. So that's an indication of the magnitude of the difference between those two values. And we can do the same with the other two channels. So let's just grab that. We'll say green, green, and of course blue, blue. Okay, so that gives us, hey, we're getting close. Only a couple warnings. So this will tell us a magnitude of difference. If we pass in two identical pixels, we'll get 0 back. If we pass in two very different pixels, we'll get a bigger number. So we've got our closest match and our closeness set. And I see I used the wrong thing there. Oh, no, I did use the right thing. Sorry about that. I was reading that all wrong. Okay, now we want to loop through the palette. So let's go for color for pixel in palette. So we're looping through the palette. If actually I'll do an assign so it's easier to read. I'll go let delta equals, we're going to take the pixel and we're going to actually, yeah, we're going to take the pixel and compare it pixel delta self. And now that I've written that down, I'm thinking this would be better the other way around. Where I say, yeah, so I'm just making a little change for readability. I'm going to take this. It's really equivalent, but I'm just trying to make this method as readable as possible. Okay, so that'll give us an int. Okay, so we're going to look at each pixel, and if the delta returned is less than, okay, I'm going to call this the best match so far. If the difference is less than the best match so far, then we've got a new candidate. And we can say that the closest match is equal to this current pixel. And the best match so far is equal to this delta. Ooh, that reads pretty good, I think. And finally, when this is all done, we're going to return the closest match. Okay, and let's see, what did I miss? Oh, I think I just missed a parentheses or something. Doesn't look like it. Very odd. You know what? Since it's complaining about this, and since this is a little hard to read, I'm going to instead do this. I'm going to go let r delta equals this, and maybe it'll see. Maybe we'll see if I got something wrong. Let g delta equals this. And let B delta equals this, and there we go. That's a little easier to read, actually. I like. Okay, so we've got our closest match. We're now able to go through the palette and it'll return the one that matches closest. So let's go back to our filters. And now we can do the following. We can just, all we need to do is, we've got our pixel P. We want to call find closest match, where we pass in our 8-color palette. I'm going to call that palette 8, just so we don't lose track of the fact that we're doing an 8-color thing here. Okay. And warning du jour is, oh, right. Yes, we're inside a closure, so we want to add self here. We want to be very explicit about that. Great. Okay. Anything else we need to do? Well, we need to add this to our list of filters. And is that name long? Well, colors 8 filter sounds good. Yes. Now, you may notice that I leave a comma at the end of this array. Actually, that's kind of on purpose. I like having arrays where I leave a comma at the end, so it's very easy to add elements later, and you'll see them if you do differences in your source code control thing. They'll show up as individual items. We don't have to keep playing with the last item to add or remove that comma. I hope that makes sense. Okay, let's run it now. So we're running. We can see the build succeeded. We're just waiting. There we go. Let's go to our select filters. Awesome. Okay, and we are expecting it to look a little wonky. There we go. That's pretty wonky. Okay, well, thank you very much, and I hope you enjoyed this video. Stay tuned. Next one, we're going to be even wonkier.